Welcome to Study Loop.
Here heat flows from 373 Kelvin reservoir to 273 Kelvin reservoir through this copper rod. The heat flow through a rod having area of cross section A, length L, in time t can be calculated by using the relation Q equal to K A T into delta T upon L. Here K is thermal conductivity of the material, A is area of cross section of rod, T is time during which heat flows, L is length of the rod, and delta T is temperature difference between the ends of the rod. Now by plugging different values in the relation, Q equal to thermal conductivity for copper is 390 watt per meter per Kelvin into area of cross section of rod is 9.4 times 10 to the power minus 4 square meter into time is 120 second, which is 2 minutes, and change in temperature is 373 Kelvin minus 273 Kelvin upon length of the rod is 0.35 meter. So this gives us amount of heat which flows from the reservoir having temperature of 373 Kelvin to 273 Kelvin is 12569.14 joule. Now we can easily calculate the change in entropy of universe when heat flows from the reservoir with high temperature to the reservoir with low temperature. So change in entropy of universe is equal to change in entropy of the reservoir having temperature of 373 Kelvin plus change in entropy of the reservoir having temperature of 273 Kelvin. So this gives us change in entropy of universe equal to minus Q upon 373 as heat is released by a reservoir having temperature of 373 Kelvin. That's why change in entropy will be negative upon temperature of this reservoir is 373 Kelvin plus the heat is added in the reservoir having temperature of 273 Kelvin. That's why change in entropy will be positive Q upon 273 Kelvin. This is the temperature of the low temperature reservoir. So by taking Q common from both terms, it gives us minus 1 upon 373 Kelvin plus 1 upon 273 Kelvin. So change in entropy of universe equal to here Q that we have calculated earlier having the value of 12569.14 joule into minus 1 upon 373 Kelvin plus 1 upon 273 Kelvin. So this gives us change in entropy of universe equal to 12.34 joule per Kelvin. Now we can easily calculate the amount of unavailable energy. So the relation for unavailable energy is that is equal to T naught times change in entropy of universe. Here T naught is absolute temperature of the coldest heat reservoir. Here the value of T naught is 173 Kelvin and change in entropy of universe is 12.43 12.34 joule per Kelvin. This gives us amount of unavailable energy equal to 2.135 times 10 to the power 3 joule. That's the answer. Thanks for watching.